Continuing on with our 9.1 lesson, we're going to be talking about multiplying rational expressions. And again, we're going to ease into it by looking at multiplying fractions. So if we come down to this example, we have 5/6 times 4/15. Now there are a couple different ways we can do this. We could just multiply right across the top and say 5 times 4 is 20, and 6 times 15 is 90, and then simplify from there, pull a 10 out of each of those, and get 2/9, which is what they had in the end over here as well. So that would work. Or another way we can do this is we can cross things out vertically from all of our factors to kind of reduce them down like we did here. We took out the 10 from each piece. We can also cross things out diagonally. So take 5 out of this piece and leave 1, take 5 out of this piece, and it leaves 3. Then as well, we can take 2 out of this and leave 2, 2 out of this and leave 3, and then we'd say 1 times 2 equals 2, 3 times 3 equals 9, and that's our 2/9 again. That way also works. Or, again, we can break things down into our prime factorizations, what they showed here. 5 breaks down to just 5. 4 breaks down to 2 and 2. 6 breaks down into 2 times 3. 15 breaks into 3 times 5. And now we just cancel things away. 5 and 5, 2 and 2. And we're left with 2 over 3 times 3, which again is 2/9. So all of these methods will work. They're all viable ways to deal with multiplying those fractions. So there are also ways of multiplying rational expressions. So in this case, we're going to look at the diagonally dividing things out. So we have an 8x, and diagonally away from it is a 16x cubed. So we can divide 8x out of that, and it would just leave 1. Dividing 8x out of this piece would leave 2x squared. Now, again, going diagonally, dividing a 7y squared out leaves 1, and 7y squared out of 21y cubed leaves 3y. Now again, we just multiply right across, and we're left with 1 over 3 times 2 is 6, x squared, y. So our most simplified version is 6x squared y, or 1 over 6x squared y. Okay, let's say we wanted to try the prime factorization version. So we would break this down into 6 becomes 2 times 3 times, we could do x and x. Let's just keep it as x squared though. The variables will probably be easier to keep as powers of the variable. So x squared and y. Still across the top, 10 becomes 5 and 2, x cubed, and y squared. So that's our numerator now. Multiplying right across the denominator, we have 5 times x times y times 3 times x times y times z. Okay, now, like before, we just kind of cross out or divide out all of our common factors here. So a 3 and a 3, a 5 and a 5. So a y and a y will go away. We'll take these two x's, that's like an x squared, so that'll be that one there. And we have a y left here, which will take away this piece. It'll just be y to the 1 now. And it looks like that's all the dividing out that we can do. So we still have 2, x cubed and y to the 1. 2 times 2 is 4, x cubed y over, the only thing left on bottom is z. So our most simplified version is 4 x cubed y over z. Similarly, if we were going to divide out rational expressions, or we can kind of break that down into dividing out fractions, It's going to be pretty much the exact same as multiplying. The only difference here is, remember, whenever we divide by a fraction, we have to multiply by the reciprocal. So we can't just divide straight through. We have to flip these two around, and that would give us this 14/9 here. Once we have it as 3/7 over, or 3/7 times 14/9, then it's the same as what we did before. So let's see how that works with some examples here. If we have 3x squared y over 20ab divided by 6xy over 5a squared b cubed, that's the same as saying 3x squared y over 20ab times the reciprocal 5a squared b cubed over 6xy. And then from here you can do whatever method you like to cross them out. I'm going to use the diagonal method again. So we'll take 3 out of that, 3 out of that, 1x from here, 1x from here. Take out these y's. Diagonally over here, we'll take a 5 out and a 5 out. We'll take an a out and an a out, and one b and one of those b's. So this is what we have left on the bottom here. Now, multiplying straight across, we just have our x here, our a, and our b squared. So we would say a b squared x over 4 and 2. 4 times 2 is 8. So that is our most simplified version of that rational expression. All right, now if we have polynomials in both the numerator and denominator. So before we were just using monomials, now each of these is a polynomial. So remember, the best way to do these is to factor it out into its smallest factors and then use those. So, like before, the first thing to do is switch it into a multiplication problem. So k minus 3, k plus 1, times, instead of divided by, our 1 minus k squared on top, k squared minus 4k plus 3 on bottom. Okay? Now from here, we'll just break it down into those factors. So we've already got these ones as factors. One thing you can notice about this is if we pull out a -1, this piece would become a difference of squares. Put a negative and a positive there. So that would make it a lot more easy to factor. This bottom piece down here, we would want to factor as well. So let's give us a little more room, and we'll see exactly what all these factors come out to. We take out that -1 over here. I'm going to write to this on the side here. Taking out a -1 would leave us with k squared minus 1. And we know that k squared minus 1 is a difference of squares, so it would be -1 times k plus 1, k minus 1. So this is going to be our numerator over here. So -1, k plus 1, k minus 1. This piece we can still factor as well. If we have k squared minus 4k plus 3, looks like that one can be factored down into k minus 3 and k minus 1, because that -3 and the -1 would multiply to 3, and they would add to -4. So now we have all of the factors broken down. Now again, all we got to do is just cross out any doubling ones. And you can do that vertically or diagonally. So here we have k minus 3, k minus 3. Here we have k plus 1, k plus 1. Here we have even a k minus 1 and a k minus 1. So the only thing left in the end is -1 on top and 1 on bottom. So it looks like this one actually, most simplified version, is just negative 1. Nice and easy. All right, let's try that with our last polynomial in the numerator one. This one is already a multiplication problem, so we don't have to worry about flipping it. So all we have to do is find the factors. These ones are already factored. This is a difference of squares, so we would call this piece over here x plus 3 and x minus 3. This piece here we can factor. We need something that would multiply to 6 and add to 5. So it looks like we would use x plus 3 and x plus 2. So I'm just going to kind of cross this out. So we have x minus 3 over x plus 2 times x plus 3, x plus 2 over x plus 3, x minus 3. Now again, vertical and diagonal crossing out or dividing out, x minus 3, x minus 3, x plus 2, x plus 2, and x plus 3, x plus 3, which in the end leaves us with 1 in the numerator and 1 in the denominator. So our answer is just 1. 1 is the most simplified version of that rational expression.